All right, so now we're going to do an integral by using partial fractions, and we're going to do a little decomposition of this just like we did in the previous video, just a little bit quicker this time. So we're going to take an off to the side and we're going to decompose this into two fractions. So we're going to take our x squared plus x minus 6 and we're going to factor the denominator. So that's the one that we want to split up. So that's x plus 3, x minus 2, and so that would give us a over x plus 3 plus b over x minus 2. And then like we did in the video, we're going to basically multiply x minus 2 by a and x plus 3 times b to make a common denominator. So this one will be multiplied by x plus 3, and this one will be multiplied by x minus 2. So now the way we do this is we know that these have to equal x minus 6. So we're going to put them in order, you'll see. So it's ax minus 2. So I like to go a times x minus 2 here, and that would be ax minus 2a. And then we do the b times x plus 3, and that would be bx plus 3b. It allows us to make sure that we don't make that many mistakes, but then at the very bottom we know that these two, the top has to equal x minus 6. So as we multiply these out, we get a x minus 2 plus b x plus 3 all over x plus 3 x minus 2 for our common denominator. So the top is what we're looking at. So the ax minus 2 and the bx plus 3 is equal to ax minus 6. So if we write it this way, you can see what it's giving us are our two equations. So if I put a 1 in front here, and I come over here and I erase this, and I put plus negative 6, then what we know is adding ax plus bx would equal 1. So that means a plus b has to equal 1. That's our first equation. And the next one would mean that negative 2a plus 3b would have to equal negative 6. So negative 2a plus 3b. So it gives us our equations that we can use to solve for a and b. And then that would give us 1, 1, 1, negative 2, 3, negative 6, which we can plug into our calculator, which we already did in the last one, right here. So by plugging it into our calculator in the previous video, it gave us 9/5 and negative 4/5. So a equals 9/5 and b equals negative 4/5. Now we have decomposed our fraction because it would become negative 9 over 5, oops, sorry, positive, not negative, x plus 3 because that's our a, minus 4 over 5 x minus 2. But what I like to do is write it this way. We write it as 9/5 times 1 over x plus 3 because we're going to be integrating this, minus 4/5 times 1 over x minus 2. So this will make it a lot easier to take our integral. So now we've taken our fraction x minus 6 over x squared plus x minus 6, and we've done our decomposition and created this new fraction. So now we go integral 9/5 times 1 over x plus 3 minus 4/5 times 1 over x minus 2. And since these are linear factors, the bottoms are lines, we can easily do an integral with natural log. So this becomes 9/5 natural log of x plus 3, because there's no other number next to the x. We don't have to worry about putting a fraction in front. There was no chain rule that happened. Oops, not times. Minus 4/5 natural log x minus 2 plus c. And there we go. So this is how we do partial fractions with linear factors. So just so you can see another one, we're going to do it again. All right, zoom in. There we go. All right, so again, the first thing we do is factor the denominators. So this would be x, they have in common, and then 2x squared plus 3x minus 2. And then that's our trinomial, which would be 2x and then x plus 2 and a minus 1. And then we double check it, so that would be 2x squared. 4x take away x is 3x, negative 2, it checks. All right, so now we have three factors. So this would equal, well, that won't equal it. our fraction would equal, because we haven't found the integral yet. That would be a over x, that's our first one, plus b over 2x minus 1 plus c over x plus 2. So now we have 3 letters. So we're going to end up with our 3 by 3 matrix. Okay, so that means that the A needs both of these, the B needs both of these two, and the C needs that. So we just write it that way. A has to be multiplied by 2x minus 1 and x plus 2, because that's the two denominators that it would need, top and bottom. Our B needs to be multiplied by x, we just put an x there, and x plus 2, because those are the two that it's missing. And then the C is missing the x and the 2x minus 1. So now we just have to multiply these out. So we write A, B, and C just like that, so that we can distribute these polynomials. So we would end up with these two being multiplied, or we already know that that is this. So we can just put 2x squared plus 3x minus 2. And then this is a quick one. It's x squared plus 2x. And then this would be 2x squared minus x. Okay, so everything here is being multiplied by a. So let's write this out. They're all nice and lined up. Our top would be x squared plus 2x minus 1. So each of these would have a, each of these would have b, and each would have a c. So our first equation would be 2a x squared plus bx plus 2cx squared equals x squared. So that is our first equation. It would be 2a plus b plus 2c is equal to 1, because there's a 1 there. And then our next would be 3a, 2b minus c equals 2. So 3a plus 2b minus c equals 2. So we already know that all of these are going to add up because they're x's. These are all x squared. So we don't have to write the x squareds. It's just the coefficients that have to match. So 2a, b, and 2c has to be 1. 3a, 2b, and negative c has to be 2. And then the very last one is just negative 2a. So negative 2a has to equal negative 1. Like that. So we can actually plug these into our calculator and use matrices, or you can solve it out. And just to keep this consistent on this page, we'll do a different method in the next page. We're going to write negative 2a plus 0b plus 0c equals negative 1, because really there's a 0 here and a 0 here. So you can see this is our matrice. That's row 1, row 2, and row 3 for our matrice. So that's what we're going to plug in our calculator. 2, 1, 2, 1. 3, 2, negative 1, 2, negative 2, 0, 0, negative 1. Just like that. Okay, so now we're going to input this into our matrix, and it'll tell us what our A, B, and C is. So we're going to scroll to edit, enter. This is a 3 by 4. So 3, enter, 4, enter. And then 2. Just entering a left to right, just as you read it. All right, and then we double check it. 2, 1, 2, 1, 3, 2, negative 1, 2, negative 2, 0, 0, negative 1. All right, second quit, and now we got to augment this matrix. So second matrix, we go to math, scroll up until you see RREF, which is B. Go back in and select the matrix that we just created, parenthesis. Go back to math, fraction, enter, and there they are. So A is a half. B is 1/5, and C is negative 1/10. So A equals 1/2, B equals 1/5, and C equals negative 1/10. So now we know what our fraction is, so we can actually write it over here. So I'm going to move this stuff over to get out of the way, and now we can rewrite it. So again, we're going to write integral, and so our A here is 1/2. So our first fraction would be 1/2 1 over x plus, and then 1/5 times 1 over 2x minus 1 plus oops, in this case minus, sorry, minus 1/10 times 1 over x plus 2. And now we've broken it up so we can use our natural log. So the first would be 1/2 ln of x plus, and then this is going to be, has a 2 in front, so we're going to need to put a half in front. So this is 1/5 times 1/2 times 1 over, oops, ln of x minus, I forgot the 2, 2x minus 1. And then just always verify it. So that would be 1 over 2x minus 1, which is right there, times 2, and it cancels with the half. And then the last one's just a nice quick one, 1/10 ln x plus 2 plus c. So if we combine this, this is 1/2 ln of x plus 1/10 ln of 2x minus 1 minus 1/10 ln plus c. That's it. So the whole main work is for these linear ones is really just getting through the partial fractions. The integral after that becomes very, very simple. It's just a lot of natural logs through there. All right. The next video, we will look at repeated linear factors, and then what do you do there?